Hi everyone, welcome to the second Quantum Computing Weekly Recap. This week we have some cool news about different companies working with quantum, hopefully reaching quantum utility soon. We have some governments buying and funding quantum. We have open source news, and we even have some events that happened. So let's get right into it. For the first story, Telefonica Germany was actually working with AWS to see if they can use quantum computers to find the optimal placement of different radio towers to maybe improve their services and develop 6G networks. So, 5G, you don't get much of a distance with your reception, and they don't go through walls or materials very well. So what this is trying to do is figure out, well, can we use quantum to optimize the positions of all the different radio towers? And it could be using something like a graph or some kind of quantum advantage algorithm, maybe even just quantum optimization to find a minimum energy of that graph, or even Grover's search to find the best distribution maybe. I'm not sure how they're doing it, but it's very interesting that they're going to try to use quantum here. I'm curious to see if they can outperform a classical computer at this point, because if they can find a better position with quantum, well then I think that's our first example of quantum utility. So I'm really hoping that Amazon is able to optimize and work with them to find the best placement and then get some 6G networks in Germany. That'd be awesome. The second news we have is IBM and Pasqal are working together. I'm really excited for this because they're actually building a new plugin or a new provider for the Qiskit ecosystem, where now we can actually use the Pasqal computers. I've been really looking forward to using Pasqal. It's a very interesting company, great company. They use neutral atoms, so we'll be able to see if this will be, I think, the first neutral atom we can use with Qiskit, and most people are using Qiskit. So very excited to see where this goes, and when this is released, I definitely will do a video showing the new provider. So that's exciting. Now we have the Algorithmiq company had a cool error mitigation technique called Tensor error mitigation. Yeah, Tensor network error mitigation. And what it was doing is it was inserting a mirror circuit inside of whatever circuit that you want to run to add error, and then it was mirroring that circuit. So in quantum, if you have like one operation and you do the inverse of that operation, those operations have to cancel. It's not like a classical computer where if I say 1 and 0, my result is 0. And there's no way to tell me if it was 0 and 1 that got me that 0 or 0 and 0 that got me that 0. You lose information in classical computers when you do an AND operation. But in a quantum computer, you can't have any operation that loses information. So this tensor network error mitigation technique was inserting these kind of opposite gates where they would immediately cancel out. Where the quantum computer isn't perfect, so even when you do those mirror gates, you'll still get some errors propagating. And they are able to use that error at the end, and they're able to use a tensor in some way to mitigate the errors, to understand the noise landscape of that computer, and then have a better, result at the end. So that's pretty interesting. I think using Nvidia chips, makes sense. Their tensor operations are crazy fast. The only fear I have is, error mitigation is not scalable. So, this is a good short-term solution, especially because, 300 times faster than using, anything else makes sense. But yeah, I think the speed is great for short-term utility, and I'm curious to see if we can use the mirror circuits and maybe make this scale better for future, thousands of qubits, but we'll see. So that was really exciting news. Yeah, Quantum Machines and QuEra, they won a Research and Development Foundation Award. And this was a very cool award, and I think well deserved, because what they're doing is they are creating, it almost seems like they're creating a custom chip that performs computation with photons. And it is kind of like the chip is programmed. You could do a Fourier transform just with photons in like linear time, because the light propagates and it's like a natural, when it curves out, when it becomes a wave, it's like a natural Fourier transform computer if you design it correctly. Um, these pulse processing units are interesting because they've created something that's even faster than an FPGA. An FPGA isn't like a linear, or I mean, it isn't as fast as light. And this is literally using light to perform operations. So I think that I'm very excited to see what performance you get when you're able to design chips that you can pass light in and get a result out. I would imagine that a lot of the quantum computer in the future would use these kinds of chips, because in the case of most of the quantum computers, when you actually read the qubits, you get light or some sort of frequency in some way as a response. Like in trapped ion computers, when you measure, the ion that you're measuring will emit a photon if it was excited, because the energy has to be conserved, and you just, it collapses the state, so you get a photon out. And you use photon multipliers, all this stuff, and then you have, some pretty clear indication of where the qubits were excited. And that would be your one state. But with this kind of pulse processing unit, if we were able to have, more systems that use the photons for computation, then maybe you could go, way higher up the stack without losing information, without dirtying up the results. So I think this is very exciting. I really like the idea of using photons for computation, especially for the speed. It might beat out FPGA or other types of specific processors that they're currently using. Taiwan Semiconductor Research Institute selects IQM Spark. So Taiwan has bought this IQM machine. IQM builds the superconducting qubits, and I'm excited to see that Taiwan is jumping on the quantum, train at this point. They're gonna be accelerating quantum computing development. It's not a big computer, right? It's only 5 qubits, but yeah, it's key here. It's so important for research and educational purposes. I think even in recent years, 5 years ago, we were all messing around with 7 qubit machines. There was no such thing as 156 qubits, from IBM now. So this is definitely the right step forward for them. It's probably not super expensive, but you get to explore some different algorithms and proof of concepts, and especially understanding the way the computer works, how to do error mitigation, maybe even some basic schemes for like error correction, though I doubt 5 qubits is enough. But it's a really good first step for the Taiwan Semiconductor Research Institute. So I'm happy that they bought a quantum computer, and are going to be messing with it. We have some cool news from different governments now. So we had Taiwan, and now we have India. And India just announced that they supported 8 quantum startups under their National Quantum Mission, which is giving funding to quantum companies that they believe are worthwhile. We have laser diode systems. We have quantum sensing with atomic clocks, superconducting detectors. Not sure what that is. And the materials detectors for quantum sensing. A lot of people are thinking that quantum sensing is going to be one of the first really important methods for quantum utility, and I think that could be right. That or the chemistry applications. So I'm excited to see India really jumping on quantum. I love that the government is funding these 8 different startups. And I think, more governments need to support their different companies. In the US, we have the NSF, awards that you could be granted with quantum, but it's good to see that India is funding, these 8 companies. A lot of them are from IIT, yeah. Okay, then another thing I'm excited about is the Alice and Bob company. They use cat ions, and they are now releasing a local simulator for their cat ions. I definitely want to mess around with this. They give you a simulator now, a local provider that you're able to use, and you can pretty much program at the native gate level, which is exciting. You can do a bunch of different experiments. This is probably the emulator that they're using. It looks like, it's a 1-qubit emulator, and it's a French company. And we can see different results here. So I'm excited to see that and use it, because I've never messed around with cat ions, and Alice and Bob is an amazing company. So great work to them on creating, an open source local simulator that we can run with Qiskit. I mean, that just opens the door for so many people to mess around with their, with their hardware, and even prepare for their hardware. I mean, what is that? 40 qubits? Dang, that's amazing. Yeah, so 40 qubits. Wow, that's insane. That I don't know if you can even run that on a computer. How did you even simulate that? I'm not sure. I'll have to mess around with that. That's really cool. So yeah, good job, Alice and Bob. And then we have some cool different conferences coming up. So Q2B is a really popular one. They have a couple different locations as well, but here in 2024 in Silicon Valley, I guess Santa Clara, from December 10th to 12th. Yeah, December 10th to 12th, 2024. So the upcoming Q2B conference is coming, which is fun. So I'm excited to see the news from that, different companies showcasing their new products or different startups. Then we had Oak Ridge National Lab hosted a hackathon called the Southeastern Quantum Conference, and looked like it was a smashing success. A lot of cool people talking on the board. It's always nice to see OR now. They're super supportive of quantum, so it's great to see them hosting this and educating people about quantum, having fun with it. The UK had their Quantum Hackathon, the UK Quantum Hackathon. It is a government-funded organization for quantum, and it looks like they had a lot of fun. We had some cool winners. Yeah, risk aggregation evaluation for insurance losses. I met somebody from Farmers Insurance in New York, and they were using quantum to try to do the same thing. And no, he's not one of these guys. But yeah, that's pretty cool. And they even show, Continuum IonQ Classic. Nice. So really interesting work. I think getting all the students and everybody involved in using these quantum computers, it teaches us so much. I love when I go to hackathon and I hear people using, SDKs that I work on, and they're like not able to figure out how to import all this stuff, and why is there so much to import? That's great for me to know. I try to cut down and improve it for the user. So these experiences help everybody in the industry, so it's really good to see that. Thank you so much for watching the second weekly quantum computing news recap. I will definitely be back next Saturday, and I hope that this video made some sense. I'll try to keep improving it. And if you want to stay following and catching up with all these different news stories, be sure to subscribe and like if you like it, dislike it if you didn't. But if you didn't like it, leave a comment so I can improve the next video. Thank you so much, you guys. See you next week.